example 5, we have an absolute value equation where we're set to an algebraic expression. But if we keep thinking of our GEMDOS as our guide going backwards, we already have our grouping symbol isolated. So now what we have to do is we have to break it into case 1 and case 2. As soon as you get your absolute value isolated, you've got to break it into 2 different cases, and then we can drop our absolute value. So that is our mechanism. That's our strategy. So whatever's in here could either be a positive or a negative of this value out here. So that means my 4x minus 1 could equal a 5x plus 37, or the stuff that's in that absolute value, 4x minus 1, could equal the opposite of that 5x plus 37. So these are the 2 equations I have to solve independently. So I'm going to take the left side over here, case 1, and what I want to do is I want to get the x's on the same side, so I'm going to subtract 4x. So I got a negative 1 equals x plus 37. Then I want to subtract 37. So negative 38 is equal to x. That's one of my possible solutions. Now, I say possible because when they're equal to algebraic expressions, they're more prone to these things called extraneous solutions, which means we have some extra solutions that might tag along. So I'm going to have to check and see if that one's an extra. For here, in case number 2, first thing I'm going to do is I'm going to distribute that negative to undo that housing of a group. So negative 5x minus 37. And then I'm going to perform my order of operations again and try to get it isolated. So this time I'm going to bring the negative 5x to the left by adding 5x. So now I got 9x minus 1 equals negative 37. And I'm going to add 1 to both sides. Now I got 9x equals a 36 that is negative. And then we're going to divide both sides by 9. So x is equal to negative 4. And this is a possible solution. Again, I'm going to check to see if it's extraneous by plugging it back into the original. So on these, it's really important that you check them. We try to emphasize that as we went through that lesson. But I got to take the absolute value of 4 times x minus 1 equals 5 times x plus 37. So we're going to plug those in and see if they work. So the first one I'm going to try is a negative 38. So I got the absolute value of 4 times a negative 38 minus 1 absolute value. Does that equal 5 times negative 38 plus 37? Well, I'm going to solicit the use of the WABET-EMU, so I'll clear that out. I just want to do the multiplication of 4 times negative 38. So 4 times negative 38 equals negative 152. So I have absolute value of a negative 152 minus 1 absolute value. And I'm trying to make sure that that's equal to, and then 5 times the negative 38. So I'm now going to take 5 times the negative 38. Too bad, negative 38. And then I want to add 37. Okay, that's a negative 153. So I know on the right side I get a negative 153. On the left side, put that away. Come back and evaluate my absolute value. A negative 152 minus 1 is the absolute value of a negative 153. Is that equal to a negative 153? But the absolute value of a negative 153 is a positive 153, and that does not equal a negative 153. So what I found is that this solution that we have x is negative 38 is extraneous, and I want to omit it from my solution set. Now I got to go and plug the same thing in and do the same type of procedure for our negative 4. So see if I can create a little boundary here and work it on this side. So the absolute value of 4 times x minus 1 has to equal 5x plus 37. I'm going to plug in a negative 4 for x. So the absolute value of 4 times a negative 4 minus 1 is that equal to 5 times a negative 4 plus 37. So inside my absolute value, I've got negative 16 minus 1 absolute value. Is that equal to, over here I got negative 20 plus 37. So the absolute value of this is negative 17 And over here, if I add these, I get a positive 17. And the absolute value of the negative 17 is 17, and that is equal to 17, so that one checks. So after all is said and done, one of our solutions work, the negative 4, so my solution set to this one is only negative 4. I have to disregard the negative 38 because it doesn't work in that solution, which is very, very common for those algebraic expression problems where you have, at the very beginning, an absolute value equal to an algebraic expression. Be very, very cautious. Be looking for one of those to be extraneous.